And Natalia is from Lviv Polytechnic National University, Ukraine. And I will start to share my screen. And run your presentation soon. So here you are.
So good afternoon, I'm Nataliia Savchuk and I'm a master's student at Lviv Polytechnic National University. Today I will present my research about detecting millimeter scale crustal movements near critical energy infrastructure using GNSS CORS methods. The object of my research is a Dniester hydroelectric power complex, which is cornerstone of Ukraine's energy systems and critical infrastructure water security. It provides electricity, regulates water resources, and protects the region from floods. This complex includes the pumped storage power plant and two hydroelectric power plants located near the city of Novodnestrovsk. Pumped storage power plant is the most powerful in Europe and the sixth in the whole world. It consists of upper and lower reservoirs, the total volume of which is more than 100 million cubic meters with a height difference of 150 meters. Alongside the PSPP, two hydroelectric power plants form an integrated system. This unique combination enables the complex to operate in both pumping and storage modes. The complex also protects against the destructive effects of floods within a radius of 350 kilometers, covering territories of Ukraine and Moldova. However, this strategic asset is situated in a technically sensitive area. The risks of displacement and destructions have escalated due to the ongoing war in Ukraine. The threat of missile strikes and combined with the aging of hydraulic infrastructure are involving seismic behavior significantly increase the vulnerability of facilities. So continuous monitoring has become a national and critical priority. Dniester complex is located in the Ukrainian shield between the Carpathians and the Crimean mountain systems. The region is technically sensitive, located between the Volyn-Podilsky and Moldavian uplands. Even small deformation can be dangerous there, as seismic events may arise naturally or be triggered by differences in reservoirs' water levels. Continuously operating reference stations provide us long-term GNSS observations with high accuracy. Because all stations are connected in one network, they deliver reliable information about local motions. Thanks to many strict criteria, I selected some of them to use it. For this research, I used the daily observation files collected between 221 and 223rd year. By analyzing this dataset, it becomes possible to detect and assess millimeter scale crustal deformation of this complex. I based the research on 8 CORS stations. Each abbreviation refers to the settlement where the station is located. The most important for our analysis was NDNS, situated in city Novodnestrovsk, directly next to HPP1 and the huge reservoirs of the PSPP. The Dniester complex is critical infrastructure exposed to missile and drone attacks, which also makes it vulnerable to GNSS signal jamming and spoofing. So an important step was to analyze the integrity of daily solution files for the entire 3-year period. The results were satisfactory. I built 3-dimensional coordinate time series from which displacement vectors were derived. Here you can see the time series for the NDNS station in 3 components, north, east, and up. The north and up components clearly show seasonal oscillations which appear as sinusoidal patterns on the graphs. All coordinates were transformed into ITRF 2020. Also, I applied a correction using the ITRF 2020. From this model, I developed a condensed displacement field that could be applied for subtraction the large-scale tectonic motion and isolation the residual millimeter-scale local displacement. After subtraction of the condensed model, the residual displacement ranged from 0.4 to 2.2 millimeter per year, with an average about 1.2 millimeters. The largest movements at NDNS and VRBK stations indicate local zones of intensified geodynamic activity near the Dniester complex. I also created maps of annual velocities together with a condensed vector field model. After subtracting tectonic drift, we could clearly see the residual local displacement around the Dniester complex shown in orange color. I compare the displacement vectors with the geological structure of the regions and condensed grid. The correlations is very clear. The residual displacement aligned with known faults line and predictions of ITRF, which confirms the corrections of the direction determination of this process. Moving to the analysis, I identified displacement ranging about 2 millimeters per year with a predominant southwest direction. East-west deformation gradient also observed, which matches the geological zoning. These results show that the area has moved 2 millimeters more than expected by the ITRF model. I also analyzed vertical movements. The results show the general trend to subsidence caused by denudation. With an average value of about minus 0.3 millimeters per year. These findings aligned with previous researches. In summary, after correcting GNSS data with condensed ITRF model, we detected residual displacement. In fact, the area shows movements up to 2 millimeters greater than expected by the ITRF model. These results are critical for identifying zones of increased seismic risk and ensuring the safety of critical energy infrastructure. In summary, I detected residual displacement greater than expected, which are highly valuable for risk management and for protecting critical infrastructure. But the main perspective lies on the head. My integrating GNSS idea with INSAR imagery, seismic network data, and machine learning can move toward automated monitoring process and capable for generating real-time reports and providing early warnings. This will not only consolidate the resilience of infrastructure, but also offer a powerful tool for safeguarding civilians against seismic risk. That's all from my side. If you have questions, I will ask.
Thank you, Natalie. I have one question. These base stations are meant to be for this power station, or it's a national network of these permanent stations?
In Ukraine, we have a huge network. So a lot of this station is private. So I answered the companies to take this data. And I chose 8 stations near the complex, not in the power plants, but near the cities, the villages. And I create this network from these 8 stations, which is geometrically correct for my research.
Okay, thank you. Marinelli, your question? Oh. Actually, Eugene was first. Okay, Eugene, you can start.
Yeah, no, thanks. Thanks, Yanis. Thanks, Natalie. In my industry, I actually was involved with monitoring quite a lot on power stations and all that along the Danube River. So it's kind of something closer to my heart. So my question will be in relation to the results that you got. Were they analyzed or compared with measurements carried out using traditional methods like total stations and levels?
Yes, I compared with scientifics with other scientific researchers, and generally for the vectors are the same. But for this region, it's not enough monitoring research. So that's the first my research, which monitoring this proper territory near the Dniester. Because we have monitoring for a whole country, but it's very generalized. So I make it a bit closer to the power plants.
Okay. Okay, thanks. Sorry, Marinelli, to go ahead. Sorry.
Okay,
No
Marinelli.
problem. Congratulations, Natalie, and everyone else. My question is, which software do you use and why? And are all the stations from the same CORS network? Or because you said you have quite large networks and many, did you use the same CORS network, stations from the same CORS network, or they belong to different companies? and the software and why?
Okay, thank you for your questions. I use a different software. First of all, it was a basic Excel. After that was QGIS, ArcGIS. Somewhere I have a Python I would like to discover some features for me in QGIS. So I used a lot of software. And about data, I used a private data from private companies. And also I used a Ukrainian stations, which belongs to our university as well. With private stations, it was a little bit difficult, but I found the people in direct companies and just asked because I think it's very important to monitor these objects, and they said, okay, we can give you a data like a free. You can try, you can show us something new. Maybe we can improve our station's position in that region, and so in that way I did it.
Okay, thank you.
Okay, thank you, Natalie. We have to move on. We are out of time. Next is David.